This is Twit.
Just a very, very brief background. We realized that Dockers have been excellent for development, but when you start taking them into operations, when you start going to production with containers, there's some things you really have to be concerned with. And the tools are primarily targeted at making production and operations easier, and in a way that was valuable for us when we were developing our cloud technologies here at Oracle.
Well, is this a sort of thing that wasn't being solved in any way that that fit? I mean, Docker's been around for a long time, so hasn't Docker slowly evolved to solve these problems?
So in many ways, Docker does solve some of the problems, especially more recently. So obviously, when we started this effort, it was 2 years ago, and there were much more problems then. But we still use Docker for the runtime in many cases. So this is more designed as tools and techniques for building containers as opposed to running containers. And we even often build with Docker to start with, and then we use, for example, Smith to shrink the container down at the end.
Let's do an overview of what these three things actually are then. So I just read the one sentence that I stole from the website. So let's talk about each one of these things. So start with Smith. What's that about?
Yeah, so Smith is basically a tool to take software and package it up in a very micro way. So we mentioned the micro container manifesto earlier. And the idea there is not just size in order to make it easier to deploy, but also to deal with things like security vulnerabilities. When you have changes that need to be made to the container, you need to get them out quickly. To minimize security risks. When you have a whole bunch of stuff sitting in the container that's built by some random developer, you don't really know if you need to update your container for security vulnerabilities and things like that. So Smith is basically a tool to take your existing software in an RPM or even in an existing container and then minimize it so that it only contains exactly what is needed to run the container when you're operationalizing it.
Yeah, that's a really interesting problem to solve because, I see people all the time taking just like a standard, even an Alpine Linux image has a lot of tools in it that would be a big attack vector if someone could manage to escape the jail. Is that right?
Yeah, exactly. And the tools are super useful during development. I mean, I think one of the things Docker has done extremely well, especially with their Docker for Mac products, et cetera, is that they've made it super easy for developers to use stuff. And that's great when you're going through that first phase of development, when you're just trying to get stuff built as quickly as possible. But then when you need to take that and put it into production, you have a different set of concerns. And Docker developers aren't really used to thinking about that kind of thing. They're used to an operational team taking over that's, hardened their Linux and that's making sure that all the security vulnerabilities have been updated, et cetera. And suddenly you've got this big container that the developers know how to build, but nobody really knows how to operationalize and keep safe.
Okay, let's go ahead and look at the second project here, Crashcart. Let's get kind of an overview of that. What problem is that solving?
Yeah, so this is actually an interesting story because it's sort of a problem that we create by the first problem, meaning that normally you have all your utilities in your container, right? And that's very useful, as I said, for development, and it's also useful for debugging. If you then take all those utilities out because you're trying to minimize updates and attack vectors, et cetera, you need a way to go debug things that go wrong. And many types of debugging you can do from the host. So for example, you can enter the network namespace and TCP dump inside the container, et cetera. But there's a certain class of problems that you can't really do from the host. And that's when you need access to the container's file system and the file system where your tools are running at the same time. So your tools may be on the host, but say, for example, you wanted to do a very common Linux utilities LSOF. So you want to list the open files inside the container. If you're doing that from the host, you don't see the files and the sizes as you need inside the container. But if you try and change the file system into the container, LSOF isn't there, and so you can't run it. So Crashcart is essentially, think of it like the Crashcart you take and plug into in a data center when something goes wrong. So it's a way to have a bunch of utilities, TCP dump, LSOF, maybe GDB, things like that, sitting in a separate file system that you then mount into the container and can use when things go wrong.
Well, I could effectively just rebuild my container with the debugging tools in it, right? Or is that losing access to the state of an already running container that may be going awry?
Sure. Yeah, that's the one case where this becomes a little bit tricky, is if there's something going wrong and you need to live get in. Yeah, you can always have a debug version of the container, rerun it, and hope that you can reproduce the problem. But sometimes things are running in production, something goes wrong, and you need to go figure out what happened. and that's when this becomes useful. The really great thing about it is you can use it even if you haven't pre-created the container to know about it. So you can just be using any regular Docker container and then go in and load up Crashcart and get tools in there.
Okay, and so let's look at the third project. Where's the name down here? Scroll. Railcar. So what does that do for me?
So Railcar is I would think of it a little bit more on the research project side. As we were developing a lot of our internal container tools, this thing called the OCI spec, the Open Container Initiative spec, kind of came to the forefront. So we had Docker, and then Rocket appeared, and there were different container runtimes, and people said, hey, we need to have a common standard, which we think is a really important thing to have in this community, because otherwise you have a single vendor just building stuff and nobody else can interoperate with it. So the Open Container Initiative was founded, and there were two specs that they've released. One is the image spec. So Smith builds image compliant, OCI image compliant containers. And then there's the OCI runtime spec. And the OCI runtime spec is designed to be the way to run an existing container, how it's isolated by the operating system, et cetera. There's only really one implementation that uses Linux containers out there, and that's runc, which is the original version that was made by the Docker team. We felt like, hey, there really needs to be more than this. There's one by Intel called Clear Containers, but that uses virtualization instead of containerization. So we've really felt like, to be true to the spec, we need to have multiple implementations. And so we went ahead and built an alternative implementation in Rust. Rust is a fascinating language, and it has some serious advantages for this particular use case, which we can get into if you're interested. But primary reason for creating it was just to have a second implementation of a containerization runtime.
Okay, let's talk about the overall track for these projects. So this is open source. Has it always been intended to be open source from the beginning?
Yes.
Okay, and so what license is it under?
So they're dual licensed under Apache 2, because that's the one that everybody knows and is comfortable with, and it's a great license. And the UPL, which is actually a very, very permissive license as well. It's very similar to Apache, but not a lot of people know about it. So all Oracle software, there's policies to release it under that license first. And so we included that license. But then in order to have a license that people are more familiar with, we also did Apache 2, which I think is a great choice.